Hi, everyone. Big thanks to New Relic for flying me out. I'm from San Francisco. As Christian said, my name is Michelle DeTolo, and I'm here because it stopped building. There we go. Okay, cool. So I'm an iOS developer by trade. I've built and released a lot of apps. I did consulting for about 3 years, and then I spent a year at Reddit working on their mobile products. And over the course of my time building all of these apps, every single one of them has talked to a web service. It's something that people expect these days. They don't expect things on their phone to be independent of going on a website. So I've built a lot of APIs. I've designed a lot of APIs. I've spec'd a lot of APIs. So I'm here to talk about things I've learned, tell some funny stories, and hopefully we'll all have a good time. So the title of the talk is APIs, the Good, the Bad, the Ugly. So I think you can guess how the talk's going to go. I'm going to be covering a bunch of different subjects related to API development, specifically web service APIs, but if you're building a framework or some open source project, a lot of these lessons can also be applied in that direction too. So that is what we're going to cover. And with that, I'm just going to dive right in. And the first thing I'm going to talk about is documentation. Yes. The first thing, the most important thing that I want you all to remember is documentation. So what is the good part about documentation? It exists. It's true. It's true. I have definitely worked on projects that don't have documentation. Bonus points if you're writing your documentation is if it's interactive. IODocs is one of the many, many frameworks out there that I've used that, you know, as a client-side engineer using your APIs, I get to go in a browser, I get to test it. I'm not bugging you 5 bazillion times a day with what about this parameter and what about this edge case, because I can just play with it right there. So documentation, please document. The bad, well, you have documentation, but it doesn't get updated. This happens a lot, especially in early stage product development where you're working on the first version of something and you're just going really, really fast. You're deploying, but then you forget to update the documentation. This isn't great because you're working with outdated information. You're working with potentially crashers because you changed the formatting of something to totally removed a URL, for instance. That's not good. And the ugly, documentation. I've never actually seen an API that's self-documenting, and I've worked with probably over 24 in my 5-year career at this point. So please document and make sure that they're there and available, and it's going to be awesome if you have documentation. So URL formats. What's good URLs look like? Consistency. As someone who uses a lot of APIs, the less I have to do guesswork, the better. For example, if you are doing movies or anything, you want to make sure that where your IDs are consistently, you're nesting consistently so that you can kind of go from one to another, to another, to another, and they all look kind of similar. Having to relearn different parts of the same system is just going to get really confusing. And then there's going to be more different Frankenstein parts, and you're going to put them together, and you're not going to know what's going on. The bad, inconsistency. This is kind of what you can see as a typical REST example sometimes, where you have what the resource is called, followed by an ID. But sometimes you don't actually know what that ID number corresponds to if it's not being really explicit. So something like this, those might not actually be the ID of that resource. And yes, I've seen this, where you have to pass in a different ID to a different resource. It's great. Now for the fun part. Yeah, I've done this. This is actually in a production app. And this just makes me want to go, no, I don't want to use this. So being consistent, and not only with your own internal conventions, but things like HTTP verbs. They're amazingly fantastic. It lets you have to write less documentation because, oh, hey, you don't have to worry about this weird side effect that every time I try and reproduce this thing in a browser, it's going to yell at me. Payloads. So I work in JSON. XML died, as far as I'm concerned, years ago. And when I talk about payloads, I'm talking about structure, and I'm talking about, well, essentially just structure and what's in them, but mostly structure. So what are good payloads? Good payloads mean I can get all the data I need. As someone who works in the mobile space, I'm very conscious about cell connections. What if the user is on edge? Why do I need to make 7 different requests to load this one screen? So finding ways to optimize that really helps, especially in the mobile world, but also in any other world, because then you have less bandwidth. Like everyone, we pay for bandwidth. When you have a server, data needs to go over the wire, pay for bandwidth. So obviously you want all of your data, and having all the data that you need in one specific endpoint versus calling a bunch of them is really, really important. The bad. So I've seen some really interesting things in my time. And a lot of the times when you're building something for the first time, or even just as something organically grows, different people will work on different parts of a large system. Now, without documentation, without a lot of real oversight into what's going on, you can get something that looks kind of like this, where you have 3 different endpoints, all returning the same thing, but then the ID field is different in each one of them. So that means that the person using that has to then go through and check, okay, do I have an ID? Do I have product ID? Or do I have product underscore ID? And while you're thinking of this, this actually happened. I shipped an app that had that exact situation in there. And it was just a pain. That was a simplified example. There were actually 7 different endpoints, and there was this matrice of ways to get it, because some of the endpoints actually had product ID in there twice. So it was a really great API right there. So be consistent. If you're returning the same resource over and over and over again, don't get fancy, don't get clever. With payloads, so I'm client-side engineer, things I write, apps crash. There's a lot of things that cause apps to crash. So usually when I'm building against an API, I expect certain things to, be the same. For example, image URLs having the HTTP in them. When I was working on ModCloth's app, this was 3 years ago now. It was their first app. Everyone was really excited. We had our first build that showed the product detail page, and everyone was really excited. The senior VP was super excited, just got a build on her phone. The backend team did a deploy. And on this one API payload, just the one product detail, all of the images no longer had HTTP in them. So all of a sudden, this lovely VP came rushing in and was like, why are there no images? I was going to show this build to the board. So, yeah. Things like this we expect to be there, and it's kind of a contract between API engineer and the people that are going to be using it. Also, why documentation is important. Dates. Any person that you talk to who has to consume APIs will always complain about dates, because there's a bazillion, million, jillion formats out there. You have to worry about time zones, like when phones switch time zones. Oh, those are great bugs. Especially when the server doesn't send a time zone, so then you have to guess, and then the user changes. It's, oh my gosh. So things like date formats, image URLs, HTTP, something that's can this be null, for instance, is really, really important information. And we expect certain things to not change. And having those written down is a fantastic way of making sure that everyone is on the same page with what's going on. But that's not even the worst part. So I've seen some things. I've seen JSON payloads that have HTML in them, and then you're asked to parse the HTML. Like, the website can just do it. Why don't you, everyone can parse HTML. It's totally easy, right? No, don't do that. And then there's some from the peanut gallery. How about an XML response containing one element in which there lurks the real XML document as an escaped string? And these are all true, by the way. None of these are made up. That's just when things are, someone's just trying to troll you at that point and you need to go have a talk, because that's just, JSON is a data format. XML is a data format. You're not supposed to be embedding stuff. Unstable APIs are the absolute worst. As someone who's built a lot of products from scratch, I can't tell you how many times I've sent off a build and then a deploy happens and then something breaks. So please be stable. Please be stable. Authentication. This is really important. So we've heard a lot about things like SSL recently, and the security, but HTTP basic is still kind of my authentication method of choice, mostly because OAuth sucks, which I'll talk about in a second. And especially if you're working with iOS 9. So if any of you are working on backends that talk to iOS 9 apps, you're not really going to be able to work without SSL. So definitely invest in that. That also means SSL has to be secure, which is, OpenSSL kind of a thing, but it's okay, I swear. OAuth is a common standard that a lot of people use to authenticate. I'll talk about some of the drawbacks to OAuth in a second. I know a lot of people who have some really, really, really strong opinions on OAuth. So the bad OAuth, again. There are some people who really don't like OAuth, mostly because it is bringing the user out of their normal user experience on a mobile device. For web, it makes total sense because you can go to a trusted site and then you can go back. But on mobile, if you throw up a web browser, Android's a little different than iOS, but you can throw up a web browser and then only now in iOS 9 in iOS can those apps not get access to that. So like if it was a nefarious app, it could actually be sniffing the OAuth flow for your credentials, which is just really, really not good. So OAuth is still a big problem on mobile, which is why it's also bad, but it's a standard and everyone kind of knows somewhat how to use it. So that's why it's also good. It's kind of in between there. And then the ugly is when you get Mr. Bob the Builder who decides that everything else out there is terrible. I'm going to go do it myself. If there's anything we've learned from a lot of the vulnerabilities that have happened in recent years, it's that there are some very smart people who create encryption methods and security protocols, and you should probably let them do their jobs, and you should just use that because they're really complicated. And obviously, nobody has time to learn your custom authentication scheme that has HMAC and base64 encode every single payload and all of these weird things. So keeping it simple and keeping it, using one of the standard conventions that's out there is going to make everyone's life easier. Authorization. Authorization is separate from authentication. So authorization is app request permissions to do things. Some of this is covered with OAuth because you can have different OAuth scopes, but then at that point you're getting into application device, app on my device. It's allowed to access certain resources on the server versus I'm logging in as a user and I want access to my user data. I'm talking about the first one where literally you're allowed to use this thing, not have access to data. And you'll see in a second why this is really bad. So what is not so great? Single API keys. Because they're really easy to scrape from other applications. Essentially, anything that you transmit over a wire, assume that it can be man-in-the-middled and decrypted, and someone can get access to whatever that is. So if you're a really super high-profile app and you're only using an API key, chances are someone's going to steal your API key and probably use it maliciously, which is why you should do some extra security layer on top of that, because the last thing you want is your app to be out there. This is mostly, again, on mobile because it takes a while to update those, but you don't want users having to deal with like updating the app because, oh gosh, your API token got leaked and now everyone's using it and we can't use it anymore. That's not even the worst, because a lot of things happen when you don't think about giving someone access to a specific resource. There are a lot of places that really like having fully open APIs that you can just use for whatever. But obviously that costs the people who make them a lot of money because you're using bandwidth. So permissions are really incredibly important. We also have things like problems within software that have credentials leak, and you can never be really sure. Proxying is also a lot easier than a lot of people think. Charles is my favorite to use as a mobile developer because I could have my phone proxy through it. But really, anyone in their spare time can just Google it, and there's 43,500,000 results on how to proxy an iPhone connection. So if you think putting something just because it's installed software on computers are easier to hack, but if it's installed software, chances are someone's still going to be able to access your data. So you need to be careful about who you let access your data. And it also saves you time and money when someone starts DDoSing your servers with an API key, which has also happened. So, errors. We all like seeing when things go terribly, horribly wrong. So what are some good things to do when there are errors? Error codes, HTTP error statuses, please use them. There is an HTTP spec for a reason, and that's because a lot of the standard libraries that people use to consume APIs rely on those status codes, 404, 401, 402, 500, everything's on fire. Using those lets people use those libraries, makes them use your API more. Also having an error message instead of just returning, 401. 401's a little easier, but like a 402 or a 406, bad request. What was wrong with my request? Please tell me so that I can fix it. Otherwise, you're just saying, hey, there's a problem. Hey, there's a problem. But even better is human readable error messages. Because it's one thing to just have a error message. It's another thing to say, oh, hey, your zip code's the wrong length. Or, something that we can either display to users who are probably the ones doing the problem in the first place, because a lot of this time this happens with form validations, or so that as a developer, I'm using the API, I can go through and not look up error 69273 or just throw my hands up because, I don't know, I can't understand what's going on. What's not great? There was an error. I worked on one app a couple of years ago that had this kind of problem where every time we got an error that we couldn't handle, the product requirement was throw an alert up to the user saying, oops, there was an error. That was it. And so you'd be going along in the app, their server was actually kind of unreliable, so it would 500 a lot. So you'd be kind of using it, you'd be, on this random page, but some request was in the background, all of a sudden, oops, there was an error, and you're like, I don't know what caused the error. I don't know what happened. Okay, going away now. And it's just really bad for end users because, especially when you're dealing with forms, anything that is user interactionable, there really needs to be descriptive error messages. But there's more. Yeah, so 200 means okay. Error is not okay. So when you're going against conventions and standards, that means I have to write really ugly code to then inspect every payload I get back for your magic error key. And then sometimes you'll send it and it'll be an empty string. So I can't even just check the presence for the key. I have to check that the key exists and that its object has a length greater than 1. Please don't do that because that's just really ugly code that no one wants to have to write or maintain. But there's more. So what have been some of the worst things we've seen? And we go back to Twitter. So if I ask for JSON, I'm given HTML. No. Don't try and parse it. No, that's a bad idea. I've seen so many crashes happen. Not so much anymore because Objective-C has gotten, or my language Objective-C has gotten a lot better with native JSON parsing. But I've definitely fixed a lot of crashes that happen because you tried to parse JSON out of this response, and oh wait, guess what? It's not JSON. So being truthful about what your content type is, if you're asked for JSON, return JSON. Yeah, I've seen this too, where if something goes like this does not exist, it then does some sort of thing under the hood, and you end up getting a 200 with an HTML page because, you know, 404 errors don't exist on APIs, right? You don't have to worry about that. Thankfully, a lot of that is actually covered by Rails under the hood, which is kind of nice. But there are still things that you can do that you think everything's going to be okay. Don't do this to me, please. Because, okay, we're stopping the GIF now. Yeah, so that's just, it makes life really hard on, you know, someone who's using that API because they never really know what to expect. Caching. What can I say about caching? I love it when servers actually cache. So the good thing about caching is obviously when you have it, because I can't tell you how many APIs I've developed against that don't actually cache any of the responses for various reasons, various very technical reasons. But there are a lot of standards when it comes to caching, and especially when you're dealing with mobile devices, and I'm pretty sure almost every external facing API that gets developed these days at some point is going to get used on a mobile device. Therefore, every API developer, I believe, should care about this. There are a ton of really great standards that you can use and that have all the stuff built in, both on the backend side and on the client side, so it's a win-win for everyone. So cache control, this is a header, lets you set the age of something that it's allowed to live. If modified since is something that you can send, and it tells you whether or not something is new or not, which is so incredibly useful because this, if implemented appropriately, at least in my world, if I say, if modified since yesterday, it will only return me the content yesterday, or it will return nothing. It'll just give you a, I forget the status code, not changed. So give you no response body, super fast responses. People aren't mad at you for using their cell data, reloading the same list over and over again. Etags are slightly more complicated, but it is another HTTP standard thing that you can look up and it will tell you all about it. They're a little bit more complicated, but they work just as well. And it's just a way of versioning different things. So what's not so great? Manually processing data. So I used to work for Reddit. The content on Reddit is not sorted by new most of the time. It's sorted by this algorithm that we usually use called HOT, which takes into account time posted, score, and a couple other things. Now, whenever someone wanted to load new posts, it's not like Twitter because new things don't just come in at the top. So what you have to do if you wanted to be really, really good about it is have your old data, then get your new data, and then see where they overlap so you can get the user the best experience possible, not have to recreate all of these things. And oh my gosh, this is such a pain. Because having the client side have to do a bunch of processing to be like, okay, I was here and you gave me this much data, where am I? And then you have to deal with things like, what if I'm looking at new stuff, but my newest post is not in that list of new stuff you gave me? Do I have to go to another page? How do I handle that? So it just adds a lot of time to end up, adds a lot of time to showing the user something. And people are really impatient these days. I don't know about you, but if a website takes more than a couple seconds to load these days, I'm just like, I'm done with this, go back. And people expect things to be really, really fast. The more that processing data, checking for newness, checking for uniqueness, if it's a list of items that should be unique, the more that has to be done on the client side, the longer it's going to take and the unhappier the users are going to be. The ugly. Caching? I don't care. I've had that taught. Someone told me that too once. They were just like, we can't cache anything, ever. And then you facepalm. Because you don't really want to be Jean-Luc Picard facepalming. But really, there are times when things can't be cached. This is very true. If you have a lot of data that is very user sensitive, that it doesn't make sense to put on a CDN or in a mem cache somewhere, fine. But if it's something that's going to be hit all the time and all the time and all the time, first of all, that's bad for you because your databases are being read from constantly. And it's bad for the end user because everything is slower. I mean, when it comes to building really fantastic APIs, it's about the developer experience. But what it really ends up being about is the user experience. Because if you have a really sucky API, it's really hard to disguise that to your users because they're going to be waiting. They're going to see really weird things happening when they try and reload or go back or go forward or anything. So, in summary, of kind of the high-level points of what I just talked about, really good APIs have consistency, not only within their payloads, but with their structures, with how they handle different errors. And you can look at a bunch of different endpoints from the same API and recognize that they go together. If you're returning the same object from multiple different places, it should look the same. Hey, what a concept. I mean, sometimes you might need to add a little bit of data here and there, but all the basics should be there. Conventions. This is both establishing your own conventions. You know, what do our products look like in JSON? How are we formatting our dates? How are we dealing with time zones? But also the HTTP conventions that everyone knows and loves and can Google. Because if you have a public API, there's going to be people who are very new to development using it that don't understand how it works. There's a great story that, so Reddit has this one weird API to get more comments called More Children. It's a really weird name to get more comments. Yeah, right. Children, comments, I don't know. Replies, I don't know. I didn't build it. Anyway, if you ever look at the Reddit dev subreddit and just search for that keyword, probably about 25 to 30% of all the posts in that subreddit are just about that endpoint, because it takes different parameters or it returns different objects. It has different structures than every single other endpoint that Reddit has. So it confuses everyone because it is just so different from everything else that is out there. They're like going along, this endpoint's great, that looks the same, that looks the same. Whoa, what's this? And it requires you have all of this weird other information that you didn't know about. So sticking with your own conventions is really important, but also just like with the More Commons API, which is admittedly trees are hard to represent in JSON format. That was the best they came up with at the time. Knowing when to break those conventions is also really important, but break them very, very carefully. And obviously, keeping APIs simple is probably the best thing that you can do. While there's no such thing as a self-documenting API, having one that people can look at and understand without a significant amount of documentation that you're going through and reading pages and pages of is also really, really important. And that's actually all I have for you today. Thank you. There will be time for questions, don't worry.